Hi everyone, good morning. So first of all, we'll start with the why we should learn Snowflake. What is the motto to learn Snowflake? Because it's a relatively new and fresh in the cloud data warehouse space. So whenever something new comes up into the market, we will try to incorporate that things in our environment. So the same thing here, it's a relatively new and fresh. But the thing is, even if it is a new also, we will be there for some days. But if it is giving flexibility and high performance, then we will continue with the Snowflake. So here also the same thing. Even though it's a relatively new, it is giving as expected results. So that's the reason the people are behind Snowflake. Like that means like even the scratch projects or the organizations which are starting the new projects, new data warehouses, they're also going for a Snowflake, and the existing on-premises data warehouses or data transactional data, they are also ready to migrate to Snowflake because of the flexibility and ease to use. And this particular Snowflake is built purposefully for cloud platforms only. That that means Snowflake will not allow you on-premises data warehouses. On-premises in the sense a physical location will be there. There we will set up all the CPUs, RAMs, temporary memory, storage, everything will be connected and will maintain the data warehouse. But this particular Snowflake has been built for cloud platform. It can be hosted in either AWS or Azure or GCP. Any of the cloud platform we can use. So these three cloud platforms is as of today. Maybe it can increase to other cloud platforms also. We are not sure about that. And also many unique features which are not available in the existing traditional data warehouses, both the on-premises and cloud. We are having this unique features, so we are just going for Snowflake. So data cloning everywhere it is there, backing up of the data. But with zero cost is the new feature, time travel feature. So time travel in the sense we can sit today and we can go back to previous days up to 90 days. We can travel back and see what is the data in the table. So that is the concept. Data sharing feature. So you can share the data with the external vendor or internal vendor very securely with the Snowflake versus Snowflake, not using any API calls or SFTP mechanisms. With the database versus database, we can share. And reader accounts. Let's say the external vendors doesn't have Snowflake account. We can create some reader accounts. So reader accounts in the name itself, it's only for reading the data, not for writing the data. So that we can create and give to the non-Snowflake users. Out of box security. So we have security at authentication in at data level we have like row level security, columnar level security, data masking policies, other support compliances we have in Snowflake. And secure views, here this is the new concept. Views are the old concept which are available in the existing traditional data warehouses, but secure views provides the row level security. You can secure the data at row level using this secure views concept. And the most important thing is pay per whatever you have consumed. How much you have consumed, you need to pay that. And again in Snowflake, it's the pay per second billing charging. So it's not minutes or hours or day, it's a second. How much you have consumed per a second, that much only we have to pay. Again, here we have storage charge different, consumption charge different. So what is storage, what is consumption? We'll see in the Snowflake architecture class, how they are different each other, we will see there. So because of these unique features, new thing and hosted in the cloud, we are going for many people are looking at the Snowflake data warehouse to maintain their analytical data in the data warehouse. Next, what is the aim of this course? This is related to our training period. So need to get all the Snowflake features, whatever the features are available in Snowflake, we need to get the hands-on experience, not only theoretical, both practical and theoretical should be there. Only if we knew theory, what is snowpipe? So if I just say snowpipe is used for streaming the data, where to get the data wherever in the cloud, once the file is available, we can just import that file into the Snowflake table. It will not help you. We need to understand, okay, streaming of the data, fine, but how this that streaming is happening, what are the things needs to set up at the cloud level, and what are the things need to set up at the Snowflake level. All these steps, like, we need to understand, and we will do in our practical sessions every day. Like, only 20% of the classes are theory, complete theory. Like, today's class is a theory, and Snowflake architecture, it's a theory. Micro partitions, it's a theory. But the rest of the classes are practicals only. Everything we will discuss about that feature, and next we will do a practical session parallel. And so, to do all these things, do we require any purchasing of the technology? Like Snowflake, we are saying, cloud, cloud, we are saying, sorry, cloud, we are saying. So do I need to purchase that particular technology or take any subscription? No. With we have free trial account. Snowflake, you can take n number of free trial accounts. There is no problem with the same email ID, same details. You can take n number of times. There is no problem. Azure, yes, only once it is possible to take the free trial account. So we will not take at the initial step. Whenever we are discussing about the topics, Azure topics, then only we will take the trial account. So that I can explain you and you can practice at least a month. Then after that also you can use some of the free services, and some we cannot use. That is, like, only free trial versions are okay to learn this Snowflake technology. And prerequisite to this course is SQL. So if we know SQL, it's fine. Otherwise, in our curriculum itself, like, we will teach SQL, like the commands, data warehousing concepts, the join concepts, we will discuss in our training curriculum only. But prerequisite is mandatorily we need to know SQL. At least basic SQL is required. And whatever the things I am going to say, let's say we are discussing about the tables topic, types of tables. So whatever these are available, I'll explain with the live project. So live project, in the sense, let's say if you are working in a organization, you will get the task in a form of like a in the over the email or over the Excel or over the DevOps tickets through user stories, any kind you will get. So similarly, we will frame the task, and you got the task today as a work, and how you will work. What is your approach to do that task? Based on the requirement, what type of table you will create? Is it a temporary table or permanent table or transient table? What is the use case you need to apply there? So based on that, in that model or in that approach, we will teach the Snowflake project. So any doubts up to here?
Yes.
Okay. Mm,
Yes.
yeah.
Hi, Miss. I just joined and I'm just trying to figure out if this course will be the best course for me as a DevOps engineer, and what does the Snowflex do? What the purpose of it, and are we gonna operate on AWS also, or is just for Azure?
It's just for Azure, like whatever the training curriculum, Snowflake with Microsoft Azure. But I'll share the queries, like whatever the topics related for the cloud combination, stovepipe, external table, external stages. I'll share the queries respective to the AWS and GC.
Okay.
Um, Lahari, did you cover on the Python script, Python language for this one?
No, no, we will not.
Okay.
Guys, if I am going very fast, please stop me there and ask. I mean, I'll take it up slow. Okay. Okay, then these are the generic things like whatever we have discussed, why Snowflake, and what we are going to discuss in our training curriculum. Now, the history. So, on this particular history, just to get awareness on the Snowflake, we are having this history. No questions on this, like in any interview or in any examination, you will not get questions on this particular history, but you want to understand when it has started, who has developed that thing. So here, many people have this misconception saying Snowflake has been started last 5 years or last 6 years. No, it has started almost 11 years. So 2012, it has been started in California, San Mateo. So 11 years of history is there, but we are more concentrating, or it got more awareness from the last 5 to 6 years onwards. Now it is in a peak period. And who has been developed this? So this particular Snowflake has been developed by three already data warehouse experts who are having like years and years of experience on the data warehouse. They have I mean, handled many data warehouses. Like these people, particularly Oracle data warehouse, they have handled, and they have found the challenges in the existing traditional data warehouses and started designing this Snowflake. So those people are Bernard Doggle, Terry Crews, Martin Jukoski. So these are the people who developed this Snowflake. And why the name Snowflake has been came into the market, because the on the sports, like they have interest on the sport, snow sports. So on the name of that particular snow sports, they have designed the name called Snowflake. And in 2015 itself, Snowflake has been identified as a cool vendors by the company called Gartner's Magic Quadrant. So this particular Gartner's Magic Quadrant will identify the new technologies and provides awards to them. So in that way, in 2015 itself, after the uh, Snowflake started, like in 2012, 3 years it has been awarded as a first prize, like in the cool as a cool vendor. So this is the history of Snowflake, like how it has been evolved, developed. So now we will just see the evolution of cloud data platform and why Snowflake is now high in the market. So first of all, any doubts here, like in the history part? Okay, now we'll start with the evolution of cloud data platform. So first we'll discuss any cloud data warehouse or any data warehouse, not only cloud, on premises also. Any data warehouse is giving a best results or expected results. We can measure with many factors, but the four major factors are there to say, okay, this data warehouse is performing well. So those four parameters or four factors are all types of data. So all types of or all data. What does it mean? So any data warehouse, if it can process all types of data, structured data, semi-structured data, and unstructured data. So again, what is structured, semi-structured, and unstructured data? So structured data means like whatever we are seeing, the Excel data in the form of rows and columns, in the TXT data in the form of rows and columns, then we will call that data as a structured data. Semi-structured data, we might have seen these XML files, JSON files, paraquet files, ORC files, where it doesn't have the data in a full structured format, that is in the rows and columns format. It will be available in the key value and pair information. So that type of data, for just normal reading, it is fine. But for reporting purpose or for doing machine learning, that type of data is not suitable. We need to convert semi-structured data to structured data. So if that particular data warehouse is able to convert or manage, then we will say it's an ideal data warehouse. Next, unstructured data. So now we are seeing an image here, like this image is called as a unstructured data. So from this unstructured data also, we need to bring the structured data in the form of rows and columns. We have to extract the data. So if any data warehouse is able to manage this all types of data, then we will say it's a idle data warehouse. And the second factor is all users. So here all users in the sense the traffic we will say. So any data warehouse 24 bar 7 we will not have the stable or constant traffic. For some time, let's say we will take the organization example. So between the like let's say our login time is 11 a.m. Next between the morning 6 a.m. to 11 a.m. only the support team, monitoring team will be using our data warehouse. And 11 a.m. all the people will start, and up to 12 or 1 p.m the people will take work and do their activities, use the compute resources, use the data warehouse between this period. And again 1 to 2 the lunch break will be there, they'll be dispersed, and only some people will be using the data warehouse. And again it starts increase high traffic and low traffic, high traffic and low traffic. So any data warehouse, it has to manage how much traffic is there. If it is a high traffic or low traffic, it has to accept all the requests, all the queries, and provide the faster results. So then we will say it is a ideal data warehouse. So here also all users, it has to act, I mean provide the best results or expected results in a faster mode. Then we will say it is a accepting all users any traffic. So if it is accepting, then we will say it's an idle data warehouse. Next, the third parameter is fast answers. So even high traffic is there or low traffic is there, whenever the user requests some data, like let's say select star from table, it needs to bring the data from the data database storage very fastly. Then we will say it's a idle data warehouse. So this is the third parameter we are using to say it's a idle data warehouse. Next, if the new cloud is any data warehouse or the existing data warehouse or new data warehouses, when it comes into the market, we need to go features, whatever the new features are available, it's very new to us. But to work on that features, we need to have a communication language. So that communication language, if it is a SQL database, so the person who knows SQL, like let's say DDL commands, DML commands, joins concepts, some basic functions, if any person have idea, then they can easily manage the data warehouse, because the communication language we already knew, and just we want to understand how the feature works. So if we understand that and we know communication language, then it is easy to work on that particular new data warehouse. Let's say Snowflake itself. Snowflake is having features, but the communication language behind that Snowflake is still SQL database only. So it will be very easy, whoever knew SQL, they can work on the Snowflake. So here also, if the data warehouse is having SQL database as a communication language, then we will say it's a idle data warehouse, because easily people can manage the things. So all these four, based on all these four parameters, we can say, I am not saying it's the only parameters. So it's a major parameters to decide like, okay, this is a okay ideal data warehouse or idle data warehouse, or this is the best data warehouse. Based on this, we can decide the data warehouse. So these are the four parameters. Now we will see the evaluations, the four evaluations, how it has been done. We will start. So the first evolution is on-premises EDW. So EDW in the sense enterprise data warehouse. So whatever the data warehouse we are maintaining the data, it is the organization related. So we will call it as an enterprise data warehouse. On-premises EDW in the sense there will be a physical location where the setup of the data warehouse will be done. So we will get the data from that physical location, and we can access the data, we can store the data, everything can be done through the on premises only. So here, when this is the first evolution in the market, it's not, I am not talking about anything related to Snowflake or any other data warehouse. It's a generic evolution which has happened. So the first thing is on premises EDW. So here we know already four parameters. If the any data warehouse suffices the all the four parameters, then we'll say it's an idle data warehouse. So here all types of data. So in the on-premises EDW, like semi-structured and on unstructured data is unable to process. Only structured data we are able to process. That means it accepted only structured data in the form of rows and columns. It maintained in the tables. It is unable to convert semi-structured data to structured, unstructured data to structured data. So it has been failed in accepting all types of data. Next, all users. So we will call it as a scalability or elasticity. So it cannot able to accept I mean, it cannot increase or decrease. It cannot shrink and increase according to the traffic. So as it is a physical location, right? If we set up like the compute resources or whatever the compute resources in the physical location for 10 people, it will allow to work only 10 people. Suddenly if the traffic has been increased, 20 people needs to work at a time, it cannot accept because the physical location things are set up only for 10 people. So that's the reason it is unable to manage the high traffic. And even if there is no traffic, it cannot shrink the compute resources in the on premises EDW. But it has provided fast answers whatever the 10 people are requesting. The compute resources, based on that, it has provided the fast answers in this particular on premises EDW. So to work on the on premises EDW, the communication language is still SQL database only. So it's very easy. The person who knew SQL, they can handle any type of data warehouse. So that's the reason only fast answers and SQL database here it has been satisfied, and the other parameters it is unable to do. So that's the reason, based on the challenges or concerns whatever we have in the first evolution, people has started looking for the second evolution. So here in the first evolution, any doubts? I'm just
No.
moving to this. Okay, thank you. So I'm just moving to the second evolution. So based on the challenges whatever we do have in the first evolution, the second evolution, now it has been designed the cloud generation, we will call it as a, but again first generation cloud. So earlier evolution is the end on premises. Now in the second evolution, we will call it as a first generation cloud EDW. So this particular cloud evolution happened because of the challenges which are available on the on premises. Even though we are unable to match the to manage the all types of data, semi structured and unstructured data, we are not able to process in the first generation evolution. And all users, again scalability is not available in the first generation cloud, but still we are okay with the fast answers, and using the SQL database only we can manage the cloud data warehouse. So again, whatever the challenges are left in the on premises, the same challenges are still available in the first generation cloud EDW. Next, the third generation, third evolution. So the third evolution is Hadoop, big data, data lake. So these are the third evolution. So we might before 6 years or 8 years back, this Hadoop usage is more and more uh, than now. Than now, I will say why. Uh, but currently we are not using Hadoop and big data much. Even big data people are also migrating to Snowflake and other cloud data warehouses. So here we will see in the third evolution how Hadoop has been done. So Hadoop is able to manage all types of data. It can accept semi-structured data, semi-structured data, and unstructured data. It is able to process any type of data without any issue. So the challenge which we have in our first evolution and second evolution has been overcome here. Next, all users. So the scalability up to some extent it is able to process, manage. So not completely, I'm saying it's able to manage up to some extent here in the all users. But fast answers, it's failed to provide the fast answers due to the built-in process which is available at the big data and Hadoop. Next, SQL database. Whatever the to maintain Hadoop or big data, we need to learn new technologies or new languages like Scala, Python. New languages we have to learn and work on the data warehouse, Hadoop big data warehouse. But so that means like whoever new SQL database, they are unable to manage or use the Hadoop and big data. So that's the reason here we have failed to use the SQL database. I'm not saying we haven't used SQL database completely. Only basic part we have used in Hadoop and big data, but majority of the things we have used with the new technologies and new languages only. So there again people want to learn new technologies and work on the big data and Hadoop platform, so which made people like it's a tough, because again learning new language and managing the things, it's very tough. So these are the things which are available in the big data and Hadoop. So this is about third evolution. Next, the current evolution, which is complete cloud data platform. So here in this cloud data platform also, we have many cloud data warehouses. I'm not saying Snowflake is the alone cloud data warehouse. We have many things. So Azure Synapse is there, AWS data warehouse is there, GCP data warehouse is there, Snowflake data warehouse is there. Again, Oracle on cloud data warehouse is coming. So Teradata cloud data warehouse is coming. So we have many things, but how our Snowflake is accepting all the criterias, we will just understand. So Snowflake can accept all types of data. So it can accept structured data, semi-structured data, and unstructured data. Even it can convert the semi-structured and unstructured to structured data with the single function. Like we don't require any third party tools or any other ETL tools to convert the semi-structured data to structured data. With a single function, we can convert this semi-structured to structured data. So which is very easy here. And all users, because of the virtual warehouse concept, it has design like according to your usage, you can increase or decrease with a single click at any point of time. You can manage the users with the policies while creating the virtual warehouse itself. We can create the policy. Let's say my traffic, whenever the traffic is high, you just increase the compute resources. Whenever the traffic is low, you decrease the compute resources or shut down the compute resources. So that concept is available in Snowflake. So that's the reason it can manage any type of traffic, all users it can manage. So this is the second parameter also, it succeeded. And fast answers. So as the database storage and compute are decoupled with each other, so there is no dependency between each other. We will get the data retrieval very fastly, even though the same data is being used by the many users at a time, because they are independent each other. So now it may be confusing. We will see like in the Snowflake architecture class how they are decoupled and how they work. We'll see there. And as I mentioned, like a prerequisite to learn Snowflake is only SQL. If you know SQL, then there is no problem in handling the Snowflake data warehouse. So that means it is accepting the communication language as SQL, so we can easily work on the Snowflake. So now Snowflake is accepting or sufficing all the parameters which are available to say it's an ideal data warehouse. So that's the reason people are using more and more Snowflake nowadays. Even for the transactional data or analytical data, people are using this Snowflake technology. So this is about evolution of complete uh, data warehouse, how Snowflake stands here. This is the thing. So any doubts here? Okay. Now we'll see how Snowflake is acting as a data warehouse and what are the use cases we can do with this one set of single Snowflake data, we will understand. So first of all, if we see here the data sources part, Snowflake can access the data from any type of data source. So again, what is data source here? So whatever the data we are getting to Snowflake, it might be some transactional databases like OLTP databases, or some enterprise applications data, or third party tools data. So the data is maintained at the third party tools and we are using the data, or web data, even web forms, like where whatever the data, or logging of the data, that also it will accept. And IoT data it will accept. Why it will accept this? So let's say web data and log data is not in the structured format, it will be in the semi structured format. IoT data might be in the unstructured format. Even though Snowflake will accept, because Snowflake is having capability to accept any type of data. So it can accept from any source, any kind of data, it can accept from any source through any ETL tool. So we have Snowflake, I mean, we have a thing called Snowflake doesn't connect directly to any of the data sources. Let's say OLTP databases or third party tools, IoT data, it cannot connect directly with the Snowflake. We need to use some ETL tools, and then we need to get that data into the Snowflake. So again, whatever the famous ETL tools which are available in the market, like let's say Talent, Informatica, Matillion, Fivetran, all these tools can connect to any type of data source and get the data into the Snowflake. So there is no restriction. Okay, Snowflake has to use only this ETL tool, nothing like that. Whatever the current ETL tools are there, any ETL tool can accept load the data into Snowflake without any challenges. So now we are using the ETL tool to load the data which is coming from all these data sources into the Snowflake. So again, in the Snowflake, you can prepare according to your requirements, like you can process the data, transform the data, join the data, multiple tables, and maintain a finalized data, and maintain a historical data. There is no problem. So these particular Snowflake data can be used in multiple ways. One is data warehouse. So we knew, like let's say, if we have all types of information, the different aspects of the information maintained in a one place, we will call it as a data warehouse. So here also in Snowflake, you can maintain multiple types of data, multiple aspects of data of an organization. We will maintain that which is called as a data warehouse. So we can maintain the data warehouse by using this Snowflake data. And data lake, let's say if you want to do processing of the data, like converting of the data needs to be done, or if you want to do some transformations, then that type of things also can be done in a Snowflake. Not only storing the historical information, even you can process the data with the help of SQL functions. There is no problem, because SQL will be accepted. SQL is the communication language for Snowflake, so we can maintain a data lake. Even data engineering can be done. So once you loaded the data and you want to do some data engineering, that also can be done. Data exchange, so we have the concept called data share and database replication. So you can exchange the data with the external vendors or internal people very securely between the database versus database with the same data whatever we are maintaining. And data applications, by using the Snowflake data, you can directly connect to the front end applications and show the data on the web screens, like whatever, like a live also can be done with the Snowflake data. That means Snowflake is even used as a backend for the front end applications using the Java language, all this JavaScript. So that also can be done. And end of the day, data science. So Snowflake is holding years and years of data, because it's a data warehouse, analytical data warehouse. It will be holding years and years of data. So using the data science algorithms, everything, we can just generate some plans, decision making, forecasting, the things we can do with the one set of data. So that means one set of data can be used in a multiple use cases. These are the use cases. And again, we know Snowflake is hosted in the three cloud platforms: like GCP, AWS, and Microsoft Azure. So according to your organization requirement and which location is suitable, because all the three cloud platforms are not distributed across all the regions. Some are available only in some regions and some are not available in the other regions. So that's the reason where your project is situated or your headquarters is situated, where the huge usage of this data is more, from which part of country or region is more. So we will just go to that particular region. We will select the region and work maintain the Snowflake here. So this is the like Snowflake use cases and how the data will be available, which are the clouds, and who will be the using data consumers. So we can monetize the data, we can sell the data, and reporting purpose we can use this Snowflake data. And for any ad hoc analysis you can use this data, because we have historical data and also we have current data. So real time analytics also we can perform with the single data. So these people are the data consumers. So the same architecture we will explain in our project also. So we will get the data from the OLTP database, like let's say SQL Server or MySQL. We will get the data, and that data will be loaded into the Snowflake through ETL tool. So I'll explain through Talent. The data will be loaded into the Snowflake. Again, based on the Snowflake data, we will maintain a data lake and data warehouse. That means we will just process the data. We will get the raw data from the OLTP database, and we will get the raw data. That raw data we will transform according to the requirement, business requirement. And once the data is available according to the requirement, after preparation, we will give the data to reporting team. So reporting team, here we will show Power BI. So for the Power BI, we will give the information to the to generate the reports. So the same concept we will also do in our project explanation. So this is about modern data architecture. Any doubts here? Okay. So we'll just see the core features which are available in Snowflake. So Snowflake is called as a software as a service, SaaS. So what does it mean? So let's say we have used Gmail very frequently, right? So how you will use Gmail? Just you will enter in the browser Gmail, and you will provide your details, email ID and password. Then you will enter into the Gmail page. There, if you want to delete, you can delete. If you want to send a new email, you can do, or you can manage the emails according to the category, or you can star it. Everything you are doing it in the browser only. No need to install the Gmail tool into the laptop or system and again open it. Nothing is required. So that also can be possible, but even we can connect with the browser itself. So wherever the technologies they are giving a software as a service, a readily built software is provided as a service, then we will call those applications are software as a service. So Snowflake is also similar thing. Snowflake, we will not install, configure, nothing, no software, no hardware maintenance is there. So we will just through the URL, one URL will be there for your Snowflake account. We will just paste that URL in the browser and we'll provide our login details, what is username and password, and we will enter into the Snowflake page. There we can create the objects, drop the objects, insert the data, play with the data. Everything will be done. So that's the reason Snowflake is called as a software as a service. A readily built software has been provided as a service, this Snowflake. But so that means Snowflake will not update its software. Yes, it will update, it will it also have patches, everything. But the thing is, it will not come to us. At the back end itself, the maintenance, releases, everything will be done at the back end itself. No maintenance, no outages. Like the now software is being updating, like new release has been done. It's getting updated. So should we shut down our all applications because there is a downtime? Nothing is like that. So at the back end you can do your work, there is no problem. Everything will happen at the back end only. And here three cloud service providers are accepting, I mean, Snowflake can be hosted in the three cloud service providers as of today. Now, the second feature is pay only for used compute and storage. So, first of all, we'll understand, like just a basic understanding, storage. Storage in the sense, like you can store some years and years of data. Your 20 years of data can be stored in a table. And if you are not using that table, maybe for this year you are not using, next year you are using. So, at that time, only for storing you can use that, you can pay the storage cost. If you are using that data, then we will call it as a compute. So what does using means? Using means if you are trying to retrieve the data, selecting the data from the table, or if you are doing any DML operations like insert, delete, update, merge, you are doing on the data, then we will call it as a using of the data. So if you are using of the data, then it will become compute charge. If you are just storing, then it will cost storage. So these two are different to each other. Storage and compute charge independently, and that too only for usage. What is this? That too only for usage. Whatever, how many seconds you have used the data. So let's say you have used only one 110 seconds. So you have to pay only charges for 110 seconds, not for 2 minutes. So here it's a pay per second billing. So that's the concept. If there is a data of TB without processing or computing, that means using, then only storage costs incur, because this will be done. I mean, in real time projects, we will maintain historical information without using that data in Snowflake. So at that place, we need to pay only storage cost. Next, build for the cloud. So here we have challenges in the on-premises. We cannot scale the compute resources very fastly in the on-premises. So our cloud evolution came into the market. So this Snowflake also hosted in the cloud only. All the native features are from cloud native features are available. So here storage and compute are decoupled. That means they are not dependent each other. Storage work and storage costs are different. Compute work, compute layer, compute charges are different. They are completely different. And here all kind of use cases are supported. Like we can use the data as a data warehouse, data lake, data engineering, data exchange, data application, data science. In any use case, your Snowflake data can be used and can share the data to internal and external customers very securely. So this is for build for the cloud and scalable. So as I mentioned, based on the traffic, it can increase and decrease the compute resources according to the requirement. If we just set a policy kind of thing, then it automatically increase and decrease based on the usage or traffic. So that concept we will achieve with the help of virtual warehouses. It's a Snowflake object. So we will create a virtual warehouse with some set of policies, and we can achieve that scalability. So here scalability is virtually unlimited, because we can increase up to like a huge set of compute resources. So how I will say, we have virtual warehouse sizes, which are the measurement of t-shirt sizes. It starts with extra small, and we have up to 4 extra large. So we can increase between these, in this between, like according to your usage, you can increase and decrease automatically. There won't be any issue. So both storage and compute layers can scale as needed and independent from each other. So both the compute and storage, we can scale, increase or decrease automatically, and they are not dependent each other. So these are the core features which are available in Snowflake. So any doubts here? Okay. So here we'll just understand the value of cloud platform, like how it is giving flexibilities than on premises. We will see. So first thing is unlimited performance and scalability. So as I mentioned, so we can increase the compute resources from extra small to 4 extra large. So it means like a huge compute resources are available according to your requirement. So if the scalability is done, automatically the performance will increase. So we have unlimited here. If it is a on premises, like to achieve this unlimited, we have to build all the compute resources physically, which is like not at all possible. Next, near zero maintenance as a service. So here, whatever the Snowflake or any other cloud data warehouse, we are getting it as a service, not as a platform, like installation, nothing is there. Hardware is not there. If we are just using it as a software uh, service, so that's the reason we are not bothered about the installations, configurations, any new patches came or any new releases came. Once after the new patch is installed, anything is not working, so that maintenance activities are zero, near zero we will say, because everything will be done at backend, and they will not come to us like this is the defect or something. We will not get any information about that. Just we will get over email the new release has been installed, that's it. But we will not get any downtime, nothing. So near zero maintenance as a service. And one platform, one copy of data, many workloads. So Snowflake is one cloud data platform and one copy of data. That means only with one set of data, you can use that data as a data warehouse, data lake, data exchange, data science, data engineering. You can use that data for any kind of use case. So many workloads we will say. So this one Snowflake data can be one set of data or one copy of data can be used for multiple use cases. Next, the final thing is secure governed access to all data. So not only for data, even for authentication, everything we have some high level of security access are there. So at data level, like we have encryption is there, row level security, columnar level security, SOS mechanisms. We have many secure things are available on the data part also. So this is the value of cloud platform. So any doubts here? Okay. So Snowflake registration,
What is
like
meant by data downtime, ma'am?
data downtime. See, let's say we are installing some software or hardware in our mission. So let's say you are restarting your system. Just best example is your laptop. It will get some. You need to. We have got new updates. If you restart, then the new updates will be installed. Then we will get an option saying update and restart. That means whatever the new features came for this laptop, it will install and the restart will happen. So at that time you cannot use your laptop, right? It will be restarting mode and we cannot use the laptop, so that we will call it as a downtime. So this is just laptop thing. And if it is a real time any hardware, so hardware also they will be updating the new features, whatever the current features are there. So they will be whatever the based on the challenges or concerns, they will update that particular option or any button. They will do some updates. So at that time we cannot use that hardware whenever this updations or patches releases are installing, then we cannot use the technology or tool. So that we will call it as a downtime.
Okay, got it. Thank you.
Okay. So Snowflake's self-registration, it's just a simple process. We will get for 30 days, like or one some dollars we will get. We have to use that dollars in 30 days, or if you complete that dollars in 10 days, then the trial version expires. Again, no worries, with the same email id you can just process the same trial taking, and you can work with the Snowflake. So I will just explain this self registration when after theory classes, like when we are entering into the Snowflake practical, then at that time I'll show there this self registration. This is just with the link we can do self registration. Next, here, like while taking the self registration, we have to take consideration into few things like editions, like which cloud you are opting, and under that cloud which region you are going for. So that information we have to provide. So here we have like editions, like 4 editions are there: standard edition, enterprise edition, business critical edition, and VPS. So here standard edition is a basic edition which will not have all the features which are available in the Snowflake. So in the Snowflake, we have time travel feature, fail safe feature, multi cluster warehouses features are there. So these features are not available in the standard edition. So wherever you don't require these features in your organization, let's say your organization data is very small data set and you don't require multi cluster warehouses, time travel period, then we can go for the standard edition. If we do require those options, then we'll go for the higher editions. So from the enterprise edition onwards, all the features are supported. None of the feature is not supported. Every feature is supported, but some additional security things will not be available in the enterprise editions. So if you want to have like the such compliances like PCI, HIPAA support, then we need to go for the business critical edition. So business critical edition also works with all the Snowflake features along with this additional security things. So the final one is VPS. So it's a virtual private Snowflake. That means the cloud, whatever available, it will be like, let's say some TB of cloud is there and your organization purchased only some GB of cloud. And then the rest of the cloud will be provided to the other organizations also. So that means the cloud sharing will happen. If we go to the virtual private Snowflake VPS, then a dedicated cloud will be given for you and you can maintain your data in that cloud. So that again, like from edition to edition, the charges also differs, because in the standard edition, basic charges will be there. If we are going to the enterprise, it will increase. If we are going to the business critical, again it will increase. Virtual private means that we have to discuss, like there are no standard costs there. According to your usage and requirement, the Snowflake support will help you in guiding, like taking the VPS edition. So I'm just giving a rough thing here, and while taking the trial version, and in our next classes we will see the editions thing. Okay, so here the comparison between all types of editions. The standard edition, if we see, like all the features are not supported here. Like here we don't have time travel concept or multi-cluster warehouses, and secure views, materialized views are not available in the standard edition. So I am not going for the while taking the self trial also, we are not taking the standard edition, because we need to understand what is multi cluster warehouse, materialized views, everything. So that's the reason we will go for the enterprise edition. So in the enterprise edition, along with all the features whatever in the standard, we can have like multi cluster, time travel, materialized views, SOS mechanisms, data masking. So all these are the additional features which are available in the enterprise edition. And if we consider enterprise edition, all things are available. Whatever in complete Snowflake, all the features will work in the enterprise edition. So if we see like the charges also, if we go for the standard edition, it will cost like per hour $2. If it is enterprise edition, $3. Business critical, $4. And if it is VPS, we cannot decide that based on the storage, how much you are taking, everything, it depends on the organization data usage. They will quote the price. It's not a constant one, but for all these three, it's a constant price: $3, $4, like that. Again, this $2, $3, $4 is not a fixed one. In which case, let's say if you are using Microsoft Azure and Central India Pune region, it will cost $2. If you are going for the Microsoft Azure and some other Norway region, it may cost you $2.3. So it differs again region to region, cloud to cloud. So we will see that in the costing and pricing part of Snowflake, how it works. I'll show in the Snowflake official website only. I'll show how it differs. So this is enterprise edition. We will have all the features and security also provided. but not additional security in the enterprise. So if we go to the business critical, it will charge $4, and we have all the features which are available in the enterprise edition, and additional support like HIPAA support, PCI compliance, data encryption everywhere. All these additional things will be available in the business critical edition. So when we need to go for the enterprise or business critical, so standard we understood. If we don't want multi-cluster materialized views time travel, we can go for the standard edition. But enterprise and business critical, it is supporting all the features. Then when we need to go for enterprise or business critical, so wherever we don't require additional security information, our data is somewhat retail domain or pharmaceutical domain, so at the time we don't require high security of data, so then we can use the enterprise edition. If it is a banking domain or some government projects will be there, so high sensitive information will be there. Let's say some about country information or missiles information, so at that time we need additional security, so at that time we'll just go for the business critical or VPS editions. So based on the organization data, how much security we do require, then we will choose. Let's say we are confused to use to go with the business critical or VPS, we can contact to the Snowflake support team, and they will ask few details like what type of data we are having and how much security we are expecting. They will provide the info. We need to provide some information about our organizational data. They will suggest go for business critical or VPS. So according to your usage, they will support us. So Snowflake support everywhere, not only with these activities. Whenever you stuck with any query, like let's say you are getting some error and you don't know, you can request with the support team and they will help you on the query what is the issue. So in that way Snowflake support will help us. And Snowflake pricing, so we'll see. So I am just taking this Snowflake pricing. It's from the official page. So you can see here, it's a standard edition, $2 per credit, $3, $4, and VPS, we have to talk to the sales team. So again, like we have storage cost different. I mean, I'll explain in the architecture class. Storage cost different and computation cost different. So here storage cost per TB per month. So average of month for 1 TB it costs $40. So in this way it will differ like whichever the edition. Let's say we are going for the enterprise edition. I'm just clicking on the get started. So we will get a page where we need to fill the details, like it's nothing but Snowflake trial version. What are the steps to do to take the Snowflake trial account? So here we have to fill the details, and this we will see in our next class. Now, as of now, it is not required. So any doubts up to here? Okay. If we don't have any doubts, we will see in tomorrow's class with the Snowflake architecture class. Thanks everyone. Have a nice day.